We want to solve compound inequalities, and we want to solve compound inequalities in equations with variables on both sides by using addition, subtraction, multiplication, or division. And we want to solve inequalities in equations involving more than one step. To start with, we have an example with just one step in order to solve it. So we have b, negative 4b is greater than or equal to 12. In order to get b by itself, we have to use GEMDAS. And we have to use inverse operation, so we don't have any addition or subtraction. Next, we have multiplication, so the inverse of multiplication is division, so we will divide by negative 4. And then our negative 4 and negative 4 cancel, and we're left with b. And then we have 12 divided by negative 4, which is negative 3. And then we have to pay attention to our sign. Because we multiplied or divide by negative, in this case division by negative, we have to change the direction of the inequality. So that one's all set. And then we can look at b plus 7 is greater than or equal to 17. So we can subtract 7 from both sides. And then we get b is greater than or equal to 10. So remember what or means. Or means union. So we can put our u there. And now we can go ahead and graph it. So b is less than or equal to negative 3. So I'll just pick a spot and we'll just say this is negative 3 here. We have a closed dot at negative 3 because of the sign. So that's closed dot. And then we're going to shade to the left. Now this shading to the left means that this goes to negative infinity. That's what that arrow means. Then we have b is greater than or equal to 10. So I'm just going to pick that this represents positive 10. And at positive 10, we have a closed dot. So we have a closed dot at 10, and then we are shading to the right. So that's our inequality there. And now the last step is we have to write it in set builder notation. And in set builder notation, basically it's already written above for us. So here we have b is less than or equal to negative 3, and union b, right in red, union b is greater than or equal to 10. Now, if it's written as or, we have to write it as two separate inequalities. We can never write it as a compound inequality. Later on, when it's written as and, we will be able to write it as one inequality. So in interval notation, we have to write two separate intervals. So here we have negative infinity to negative 3. So I'll write it negative infinity to negative 3. The negative 3 is included, and infinity is never included. And our red number set over here goes to positive infinity. So our low side is going to be positive 10, and our high side is going to be positive infinity. Positive 10 is included, so we'll use the bracket. Infinity is never included, so we'll use the parenthesis. And our conjunction in this case, because it's or, we want to use our union sign. So that one is done right there. So we have our interval and our set builder notation. And we can look to the right here. Again, we want to take a look at GEMDAS, because we'll use GEMDAS to solve, to remind us. And remember, we start with addition and subtraction and work our way back to groups. So if we look at this one right here, we do not have any addition and subtraction. We just have division. So in order to get rid of division, we have to use the inverse of division, which is multiplication. So I'm going to multiply by 8 on both sides. And our 8's cancel, and we're left with r is less than 8. So that's one of our inequalities. And then the next one we can look at, we want to again, go back to GEMDAS, and we do have addition and subtraction, so we want to make sure we use that. So the inverse of subtraction is addition, so we'll add 8 to both sides. And then we get R is greater than or equal to 9. The OR, remember the OR means union, so we can put our union between. And basically, that is our set builder notation right there. So R is less than 8, union R is greater than or equal to 9. And then we can just graph those as well. And remember, greater than or equal to means closed dot. So at 9, we're going to have a closed dot, and we'll shade to the right. And then at 8, we'll have an open dot. At 8, we'll have an open dot, and we'll shade to the left. So this means union, so it just means it has to be in one set or the other. So this goes from negative infinity all the way to 8, not including 8 because it's open circle. Then we go to from 9 to positive infinity. And then we can write down these intervals. So negative infinity to 8. 8 is not included, so we use a parenthesis. Infinity is never included, so we use a parenthesis. So we have 9 to positive infinity. We use a parenthesis at positive infinity and a bracket at 9 because 9 is included. And then we want to use our union sign, union symbol, for can be in either one of those sets.